first thing, I tried to just pick the hard stuff. So find the domain of this function. So with the stuff in the root sign, what has to be true with the stuff underneath the root sign? Greater than or equal to 0. It can be equal to 0. Equal to 0 is okay. You can root 0, you can't divide by 0. Hannah, you solved inequality. Oh, I wrote x squared twice. That was not correct. You solved stuff like this in pre-calculus classes. So if you ignore for a second that this was a domain question, do you remember using number lines to solve stuff like this and making sign charts? So first you factor that. How does the x squared minus x minus 6 factor?
X minus 3x plus 2?
Yes, x minus 3x plus 2. Very good. Okay. And then on the number line, I'm going to plot where the zeros are. The zeros are at -2 and 3. Great. And then you pick test points and you test and see what is the sign of this thing on those other subintervals. So we're looking for the sign. So if I tested something like, say, -3, what is the sign of the first factor? Negative. What is the sign of the second factor? And a negative times a negative makes a positive. So you are positive from minus infinity up until -2. Does that make sense? What's a good test number between -2 and 3? 0. And just look at the first factor is negative, second factor is positive, so overall you are negative there. And then from 3 on, I'm pretty sure that's plus plus, right? Okay. So which portions of that are you looking for? The positive parts or the negative parts? Positive parts. And so as in interval, the domain will be minus infinity to -2. Do I use a square bracket or a parenthesis? Good, square bracket. And then union, square bracket around the 3 up to infinity. Say that again. Oh, if you would use the negative part if you were solving the inequality x squared minus x minus 6 less than or equal to 0. But that you will never do with a root. Well, you would if maybe you say had divided by a negative and the inequality had flipped. But the thing is, the pre-calculus class handled both of them, whereas this class, because we're specifically talking about domain, is often going to be the positive one. Okay, good question. You could also think that the graph of that x squared minus x minus 6 is a parabola, right? And it crosses the x-axis at -2 and 3, and because it's positive x squared, it's what I call a happy parabola. And the parts of that you can square root are the parts of that are above the x-axis. And you see the part that's above the x-axis is everything up until -2, and from 3 on. Does that make sense? So that's the number line and the parabola picture do the same thing. So they're equivalent. Okay. All right, what is the mathematical commandment for logs? Thou shalt not log. Not log negative numbers or 0. Other than that, so the only difference between a square root is that the stuff inside the log has to be bigger than 0. With a root, you can root 0. With logs, you can't log 0. Now this inequality, can it just solve like a regular equation? Yeah. So x is bigger than -6. What is that as an interval? And a parenthesis around -6, right? You can't do the whole true false thing. Whenever you have a question where you put like a T and an F and think your teacher's going to interpret it to be which one you want. Make sure your square brackets are obviously square and your parentheses are obviously parentheses, or I'm going to tell you that you're wrong. Okay?
What's the T?
What did you ever do that with a class you're trying to like say, okay, I think it's true, but maybe it's false, and I'll see if my teacher will just interpret it as what they want it to be. I mean, we've all tried that, right? Anyhow. All right, solve the following equations. So this one, well, it's e to the 2x minus e to the x minus 6 equals 0. We saw something a little bit like this, although it was with limits, and we factored this. The thing to notice was that e to the 2x was the same thing as e to the x squared. Does that make sense? So in some, like in my pre-calc class, I taught them that they could make a substitution and say, okay, u is e to the x, and that becomes u squared minus u minus 6 equals 0. You don't have to do that substitution.
Seems easier to look at it.
Yeah, I think it's actually personally easier to just say, okay, that's u minus 3u plus 2, right? And then you've got to put your e to the x's back in. I don't care if you skip those middle two steps. Do you see what I'm saying? Like, in my opinion, these two steps are optional if it makes more sense to you that way, okay? But if you can see, oh, e to the 2x came from e to the x and e to the x, and it's the same as regular factoring, that's also fine. Because one the substitution is to help you get good at that, so you don't have to do it anymore. We're going to use the idea of substitution in a different context later in this class, but okay. So now that you're at that stage, how do you continue solving?
E to the x minus 3 equals 0 and e to the x plus 2 equals 0.
Very good, yep. So the first one is e to the x equals 3. And how do you undo the e? Take the natural log, yep, natural log e to the x equals natural log of 3, so x equals natural log of 3. Okay, the next one you get e to the x equals negative 2. You can't ln negative 2. So this one gives no additional solutions. Because it isn't like it's no solution, there's no more solutions. One reason you can think about why this doesn't happen, what does e to the x's picture look like? It goes through 0, 1, and then it does this kind of business, right? What does y equals negative 2 look like? Horizontal line, right? And it's down 2. Another way of talking about where e to the x equals negative 2 is like, where do those two graphs cross each other? And do they ever cross each other? They won't, because the e to the x one doesn't ever go past the x-axis. So that's the geometric way to look at it. Also, it's what e to the x's picture looks like, in case you've forgotten. Don't forget what picture looks like either. That may or may not be on your test.
What?
The picture of natural log, so you have to graph a natural log. Okay, this one. First thing you would do is, what do you think? 10? Yep, add 3. Great. What do you use to undo ln? E to the ln equals e to the 10th. You just leave it. You can't work out e to the 10th on your own, so just like leave it. It's okay. Yes?
Couldn't you just skip that?
Yes. Couldn't you just skip to there? The answer is yes. If you know like if you know that what you do to one side's going to cancel, you can go ahead and cancel right away as long as you're accurate. So x equals e to the 10th minus 5. Okay.
Now, that assignment tell you to approximate that to 6 decimal places.
I think on those questions it usually didn't, actually. Because I remember Rachel had a question about that. She's like, I'm giving web sign decimals and it won't tell me that I'm right. And it's because it wanted exact answers. And also, e to the 10th so large, like, I don't think that's quite big. Okay, use properties of logs to expand the following expression. So if you have ln of a fraction, it can expand into ln of two things, and they can be, do you remember? There were these rules that if you had ln of a over b,
Subtraction.
this becomes natural log of the numerator minus natural log of the denominator. Okay, division results in two things, logs being subtracted. What happens when you have multiplication? So that becomes ln of e plus ln of x squared minus ln of y to the 7th. And this idea that we're doing this expansion thing, we're going to use it again. I'm pretty sure it's section 3.6. Can you do ln of e? It's 1. What is the one additional thing you can do with ln of x squared?
Move the exponent out.
Move the exponent down. Yep,
Why can't you move the exponent of the other one down?
you can.
No.
I was just talking, I said what was the thing you could do to the ln of x squared only? You should move both exponents down. So that's expanding it. And the name should kind of make sense because you expand it, it makes it bigger, right? Like bigger, longer.
And will they just call it simplifying? If you were gonna bring it
I will actually call it expanding. Or was your question if you go the other way?
the other way, yeah.
I would say, to go the other way, I would say write as 1 logarithm, or I could say condense. Does that make sense? But you see how this original expression was just a single logarithm?
Yeah, because I think I've seen questions both ways.
I think that, yeah, and it depends on the specific textbook semantics, right? But I think that your textbook says write as a single logarithm. The Algebra 2 textbook that I used when I taught this said do condense, but they mean the same thing. Yes?
Wouldn't you have some issues condensing that though, because you wouldn't exactly know what?
You would condensing this would be tricky because you'd have to recognize that 1 was equal to ln of e in order to do so. So I would never ask you to condense one that was quite like that. What I was testing with this one, with the expansion, was did you know ln of e was 1? But yeah, I would probably I would never on an exam ask you to go backwards with that kind of thing. I'd ask you to go backwards with something like where I left the 1 out, in which case it's a lot easier, right? Yeah, no, you're totally right. Okay, how about this one? Hollywood. We're gonna see stuff like this actually a lot later in this class, probably like next week, because later in this class isn't actually very much later. Ln of root x squared plus 1 minus ln of e to the 7th x minus 3 to the 4th. Is that first part all right?
Yeah.
Okay. There were a couple things I wanted to point out here. The first of which, what kind of power is a square root? A half. So that first term can become 1/2 ln of x squared plus 1. And there's no rule for ln of added stuff. So that ln of x squared plus 1 just stays, it's left alone. Okay, minus ln e to the 7th plus ln x minus 3 to the 4th. I made a mistake there, and I made it on purpose. What did I forget?
That one's -2.
Yeah, you need to put parentheses here. Remember how whenever you have something that expands into more than one thing that comes after subtractions, how you need parentheses? The other way to think about it is that both of those pieces are in the denominator, which means they're both negative exponents. So they should have negative signs in front of them when the power is pulled down. So that's 1/2 ln x squared plus 1 minus 7 minus 4 ln of x minus 3. Just to make it totally clear what I mean by the negative exponent thing, I could have taken the original thing and written it as ln of the root times e to the negative 7th times x minus 3 to the negative 4th. Does that make sense? And then because they're all multiplied, that would become ln of the first thing plus ln of the second thing plus ln of the third thing. And then what happens to that when you pull the exponents down? Slash do the cancellations. You get the same thing as before, right? If something came from a denominator, when its power is pulled down, it should be negative. So, okay. I made my poor pre-calculus students do this on an exam.
No.
Yeah, it's a question from your textbook, and it's not nearly as hard as it looks. This is write it as a single logarithm. So the first thing that I would say to do is to bring that 1/3 up. Does that make sense? So this becomes ln of x plus 2 cubed. What kind of power is that 1/3?
Cube root.
Cube root. Okay. And then plus 1/2 ln x minus 1/2 ln of x squared plus 3x plus 2 squared.
We have a cube root inside of a cube.
Yeah, what happens when you do a cube root of a cubed?
Well, they just cancel each other and go away.
Bye. Yes, they'll go away. I didn't want to cancel them right away, but yes, they do cancel. Plus 1/2 ln x. Oh, and I'm sorry, I'm going to write that as ln of square root x, if that's okay. And this becomes minus ln of root x squared plus 3x plus 2 squared. And much like the cube root and the cubed cancel, what happens to the squared and the square root? They also cancel.
If we had to go back the other way, we'd end up different, wouldn't we?
Yeah, you would, and that's because the point of this problem, you'd have two things that were just equivalent. And it's kind of like the case that this thing wasn't completely simplified because the powers weren't pulled down. Does that make sense? Yeah. Minus ln of x squared plus 3x plus 2. And I'm going to employ my favorite Russian math teacher's technique. Her technique now is to write ln and make a fraction bar. I think it's a great technique. Everything that's positive ends up in the numerator. Everything that's negative ends up in the denominator, because those are negative powers. So which parts end up in the numerator? And in the denominator is x squared plus 3x plus 2. I'm going to factor that into x plus 2, x plus 1. Does that make sense? Is that okay? I just did two things at once.
I'm looking to see if we can cancel it.
And you can, can't you? You just get ln of root x over x plus 1. I made that an extra credit question. One of the tests I gave my pre-calculus kids was like a question from their calculus book, and I was really happy that a lot of them actually got it right. I was pleasantly surprised. I thought I would trick you guys, and you were too smart for me. Woo, good job. All right. Okay, solve this equation. I'm going to do it wrong and try to explain why what I'm doing is wrong, okay? Here's what students try to do. This is wrong, don't write it down. They try to go E, E, E. Okay, can you see how that would happen?
Yeah.
Yeah, you like that, okay. It's not right. Here's why. If you say have like x squared plus 1 equals 9, do you just get to do root, root, root? No, what do you have to do? You have to like root 1 whole side equals root 1 whole side, right? Does that make sense? The same thing is true for E. So if you're gonna E it, you have to put one side into the exponent, put the other side into the exponent. So we can do it that way, okay? E to the power of ln x plus ln x minus 1 equals e to the power of 0. But the whole side has to go into the exponent. Okay?
How would that help at home?
That's a good question, and it'll help. I promise it'll help, okay? What is e squared times e to the third? E to the 2 plus 3, right? So generalize that pattern to my left-hand side. Do you see what I mean? This is kind of like the 2, this is kind of like the 3, right? Becomes e to the ln x times e to the ln x minus 1, right? Equals e to the 0, which is 1. Do you see what happened there? We kind of undid the fact that when you multiply things that have common bases, the exponents add, right? So now when this stuff cancels, you end up with x times x minus 1 equals 1. Or x squared minus x minus 1 equals 0. Here is an alternative, okay? And the way that I would have preferred to do this it would have been easier to take those two logs and make them into one. Does that make sense?
Because then you can have the answer.
And then, well, then you're gonna get the same answer, right?
Yeah, I like that one better.
It is significantly easier, but I really wanted to explain why the other way is, why just E willy-nilly is bad, okay? So if you see two logs, it is best to put them into one log before you E. But if you do it this way, it will work, it's just tricky, right? That's a tricky, clever application of exponent rules. In any case, this problem is just masochistic. When you get to this point, what do you have to use?
The quadratic formula.
Yeah, because someone was evil. I think actually the problem is stuff doesn't factor nicely when you're working with these kinds of things. Remember that b squared minus 4ac over 2a? So what's that? Positive 1 plus or minus the root of 1 minus 4 times 1 times negative 1 over 2. So I believe x is 1 plus or minus root 5 over 2. Does that look right?
Yeah.
Okay, and to make it even more masochistic, it's actually only 1 plus root 5. Just an awful, ugly problem. Why is 1 minus root 5 problematic?
Because you can't take natural log of a negative number.
Yeah, 1 minus root 5 ends up being a negative number, which you can kind of guesstimate that, well, root 5 is bigger than 2, because 5 is bigger than 4. So it probably won't get that tricky on your test, but the point was is condense logs if you can.
Can you take logs of imaginary numbers?
There is no system for logging negatives. So basically the question is, the answer is there's no equivalent to the fact that there are imaginary numbers for square roots for logs. And if there is, it's just not common. Does that make sense?
Yeah.
You probably won't see it. Yeah.
Sorry, I just like number
Because 1 minus root 5 over 2 is a negative number. And if you try to check it in the original equation, you can't log negative numbers. It's a technical detail that I wouldn't dock many points for not getting, but yeah, that's the reason. Okay. Alrighty. Find compositions and their domains. Okay, so f of g of x, that's f of g of x. So what goes in for g?
Root x.
Uh-huh. So that becomes cosine of root x. Okay, so there's the composition. So first look at the inside thing. The first thing you're doing is you're rooting some number. So the number you're rooting has to be exactly. And once you know that, is there any problem with cosigning the answer you get? You can cosine anything. So this domain is x bigger than or equal to 0, or it is 0 to infinity. Either way.
So if you didn't ask for it, internal
I'd have to give it internal notation. If I don't ask for it, you can lawyer me. I respond to lawyering. So, because I was that student in the class who was like, well, you said this wouldn't be a test. You can't actually ask us this question, so you shouldn't have done that. Oh, must have hated me. G of f of x. Okay, g of cosine x. So that's root cosine x. The domain for this one's going to be significantly more tricky, right? You've got to figure out where cosine x is bigger than or equal to 0. I suggest a picture. Does that make sense? Like, look at cosine's picture and see where it's positive and give me some intervals to show me that you get the pattern. Okay, so cosine of x, let's just graph it on negative 2 pi to 2 pi. So at 0, it's 1, right? Crosses at pi halves. Okay. Does that kind of picture, right? So give me the middle one. What's the middle interval? So all the parts that you can root are the parts where the cosine is positive, right? Positive means above the x-axis. So cosine's above the x-axis from negative pi halves to pi halves. Do you agree with that? Okay, so negative pi over 2 to pi over 2. Okay, and then just give me one interval on either side. What is this interval going to start at?
3 pi halves.
Where will it end? 5 pi halves. And then do union, just dot, I'll get that you get the pattern. Give me one on the other side as well. So what's that point where you cross the,
It's negative 3 pi over 2.
and then the previous point is,
Negative 5 pi over 2.
great. I don't know of a good way to list that more like in a compact using K's and stuff. There probably is a way, but I just think that that's focusing on the wrong thing. The important thing is, can you just figure it out from intervals? You get the pattern, right? It's every other odd pi half set. I mean, so, okay, cool. All right, inverse trig functions. So how many answers do these questions have?
1.
One, okay? They're functions, they have one input, they give you one output, okay? So this says cosine x, okay, I don't know. I once did that in a high school class with the function secant, and I missed the c and just put x. Imagine what that happened. High schoolers, not good, okay. Cosine x equals -1. What is the interval that you're looking at? 0 to pi, good. Okay, so in 0 to pi, at what angle is the cosine -1? Pi. So that equals pi. Why not?
Oh, wait, no.
Because there's only one answer. So this is one answer. If the question was solve, and I just gave you the equation, then you do plus 2 pi n, right? Does that make sense? If it just says solve the equation, then you have to account for all the possibilities, right? But with these inverse functions, you restricted the domains, we only had one possibility. So functions, one answer, equations could have infinite answers. But they're related questions. That's why I'm adding the specific like in 0 to pi only.
Oh, you're saying if it was the bottom one, it is
Yeah.
sine plus 2 pi.
If it was this, it'd be pi plus 2 pi n. Okay, if that was the case. That's how they're different.
That seems a little silly. It seems understood.
People just kind of,
Bring that up to the math gods when you talk to them next.
okay, I'll do my best. Okay, sine x equals -1/2. I mean, you technically do the same thing with square roots all the time. Like, what's root 4 equal to? 2. You don't say root 4 is equal to plus or minus 2, do you? You shouldn't.
Yeah.
Depending on the context, like, if I give you root 4, the answer is 2. If I give you the equation x squared equals 4, well, then the answer is both plus and minus 2. So the root function has one output versus the related squared equation has two answers. It's a pretty similar thing, right? Inverse function has one output. This equation has many answers, as in more than one. So that's the relationship. You just don't question it with square roots as much because, you're used to them.
Just drop that too.
Yeah.
Drop that on.
Okay, so next. Alrighty, so what is the interval we look at for inverse sine? -pi/2 to pi/2. So on the unit circle, that's this part measured in that direction and that direction. And with the 1/2, you're either at pi/6 or pi/3. And with sine, you're looking at the y component, so either this half or this half. So which of those angles has the sine being -1/2? -pi/6. Great. What is the sign at -pi/3? when does tangent x equal -1 in the interval from negative pi halves to pi halves? Negative pi over 4, this angle.
Then, you're saying tangent -1, it's the same as, that's the same as arctangent?
Yes. Oh, good thing to point out, yes. Tangent -1 is the same thing as arctan. What it does not mean 1 over tangent. So this is a mistake that you've been making. Tan inverse x is not equal to 1 over tangent x.
No, I mean,
No, but you are right that tan inverse x equals arctan.
if it was given in arctan, do we have to?
Nope.
do 2 pi?
Nope, because arctan is a synonymous thing for inverse tangent, and my suspicion is that the reason that people use arctan, no one makes this mistake.
Oh, that's fine.
Does that make sense? But the thing is, tan with -1 is used enough, you have to know that that's what it means. So, okay, we good with those? It's better than we were.
So if they were trying to say 1 over 10, they just take, say, 10x, put parentheses around that.
And then say -1 power.
Yeah.
Exactly, yep. Okay, because of this whole restricted domain business, sine and arcsine don't always cancel. So be a little bit careful. So my recommendation is if you're not 100% certain that they cancel, just work stuff out from the inside out. Do you know what I mean by that? Like, can you find sine of 5 pi quarters? So that's equal to arcsine of -√2 over 2. Okay, and so then you look at your unit circle and say, okay, well, when is my sine at -√2 over 2 in negative pi halves to pi halves, and what's the answer going to be? So in that instance, did the sine and arcsine cancel? No. And the reason not is that 5 pi quarters is not in negative pi over 2 to pi over 2. So cancellation breaks down. That's how you can tell that's going to happen. But if you don't remember that rule, it will always work to just work out what sine of whatever is and then do the inverse. So it's not going to be wrong if you do it and you see that, oh, they did cancel. Okay, great, yay. But
Can you say 7 pi over 4?
no, you cannot.
Because
arcsine,
that way because it's cut off.
yep, because arcsine of x's range by definition is negative pi over 2 to pi over 2, which means all of its outputs are within that range of numbers. So 7 pi over 4 is not in that range of numbers. So it would be a little, I would give you partial credit because I would get that you knew where the angle was, but it would not be completely correct. I know, it's so tricky. I mean, yeah. Inverses are hard, and they're really hard when they're restricted to stuff. Ooh, and how do you simplify this business? What do you use? A triangle. Yep.
Do you take x and call it x over 1?
Yes, you say tan inverse of x is equal to some angle theta. And so therefore tangent of theta equals x over 1. Remember that? So in your triangle, you have your angle theta. Where does the x go? And the 1 goes? And the hypotenuse is? Or x squared plus 1, but either way, yep. And that root does not distribute because you know that, right? And once you got your triangle, you're pretty much almost done. This is find sine of theta, because theta was equal to inverse tan. And so then using your triangle, can you figure out what sine of theta is? There you go. You don't have to rationalize that. If you do, you get x root x squared plus 1 over x squared plus 1. But honestly, rationalization almost always only happens with numbers and not with things that have x's in them, unless you're working like out a limit problem or something. Okay. Does anybody feel like a little bit mind blown, that thing with sines and inverse trig functions becomes thing with just x's and no trig functions at all. Is that a little like crazy? Anybody but me?
Because I try to do it like sine, arc sine over x over cosine, arc cosine.
Oh, that's because that's not right. It's okay. It's a good thing to point out. This is not equal to sine inverse over cosine inverse. It's just not true. So you used a fact that was just not true. So that's like saying that, yeah, so no, it just doesn't work. Yeah, so you have to use the fact that when you have tangent of your angle, you can then make a triangle out of those two sides. Okay. All right. Okay, so on to limit stuff. Find the limits. This might have been a quiz question. All right, so as long as there's no funny business, you can just plug the number in, right? So this is secant of pi plus sine of pi. What's sine of pi? 0, so this becomes secant of pi, 1 over cosine pi. And what is cosine pi? So this is 1 over -1 or -1. That's how I test. If you can know that secant is 1 over cosine, you can find cosine of pi. That was clever. Hopefully you can. Is Jimmy okay with that? Or you don't like your face? Okay, how about this one? This one is tricky. We did one like this in class. Can you make the sine squareds into cosine squareds?
Yes.
Yes. How?
There's that rule, sine squared of x plus cosine squared of x equals 1.
Mm-hmm. That's the basic Pythagorean identity. So sine squared is 1.
Minus cosine x.
Mhm.
Squared x.
Yep, very good. Okay. How does 1 minus cosine squared x cancel? Good. Okay, then simplify. 1 over 1 plus cosine x, right? All right, what happens when you plug in 0 now? What's cosine of 0 is 1, so we get 1 over 1 plus 1 or 1/2. Cosine of 0 is equal to 1, think unit circle. Over there, the x is 1, right? Don't confuse it with the sign. Cosine is x, sine is y, alphabetical. I know it's really easy to dyslexify those points. Like I have to think to myself, okay, over, up, over 1, up, nothing. That's what helps me. All right. So where are these functions discontinuous? And then use the definition to explain why the function is discontinuous at that point. So first of all, tell me where.
X equals -3.
And this one actually has 2 reasons why this function is not continuous there.
X is not defined.
F of -3 is not defined,
There's no limit.
and there's no limit. The limit as x goes to -3 of your function does not exist. It's technically plus minus infinity, like from each side it's one or the other.
No, like you said,
You only have to give one. Yeah, if I ask for a reason, you have to give a reason, singular.
so you take either one of those.
I take either one of those. Yep, and that question was on the quiz that I graded and handed back before class began, and I took either answer on it. Yep. Okay, this might have been the quiz question too. Okay, tell whether these functions, so if this function is going to have a problem, where will it be? At 1. Okay, so maybe at x equals 1, and how would you check that 1's a problem? But I think what I mean is because if I take the limits of both of them. So find the limit as x goes to 1 from the left. Which half of the function would you use there? And that's going to be 2, right? X goes to 1 from the right. In that case, you're gonna use the other part, right? And because the function doesn't match on the left and the right, that means so therefore the limit as x goes to 1 of f of x does not exist.
So if I just wrote that without clarifying those first two things?
I think I would like a small explanation of why. You don't have to do as much work. You could say the left limit is 2, the right limit is 3, they don't match. But you might have said something to the effect of there's a jump in the graph, in which case I thought you knew what you were doing, so I gave you full credit because it wasn't completely clear. Yeah.
Yes, wouldn't that also be the limit as x goes to a of f of x does not equal f of a, rule number 3?
Yes, but if you're talking about the limit in that context, it implies that the limit exists. So like you can't even go to that step because the previous one is broken. So since that condition relies on the previous condition being met, I think I would prefer you give the previous condition.
Would it be acceptable to just write limit of x approaches 1 from the left does not equal?
Yes, yeah, because that implies the limit doesn't exist. Yep. Okay. So limits at infinity. Okay, so first of all, this one is tricky because instead of being positive infinity, it has negative infinity. So how do you deal with that first? Put the negative in for x and make the x go to infinity instead. So it becomes negative x plus 3 times negative x squared, 4 times negative x minus 6. So then becomes limit x goes to infinity, root negative x plus 3x squared over negative 4x minus 6. On your quiz, I didn't dock points if you didn't show your work. I'm going to do that on your test. I'll specify that in the directions this time. I didn't, so I wasn't going to punish you because I made a mistake. So what do you multiply by here? 1 over x. When that 1 over x goes inside the root, what happens to it? Squared. So that becomes negative 1 over x plus 3 over negative 4 minus 6 over x.
Where's the negative x squared go?
Oh, well, it's negative x times negative x.
Yeah, that's what.
That's positive x squared, right? That's why it became positive. Yeah. Whenever you have an even power, negative whatever to even power will be just that whatever to the power, right? Okay, so what happens to the negative 1 over x and the 6 over x as x goes to infinity? Where do they go to 0, right? So where does the numerator go to? Denominator goes to? There you go. Bam. Trickiest thing there is that when you put the 1 over x into the root, it gets squared. That's the trickiest thing, right? Okay.
I tried that to be trick. I might have done it wrong on logarithms, but I couldn't figure it out. Like, I tried to put the negatives in fractions, but
Send me the specific, send me a ask my teacher question. I'll take a look at it. My suspicion is that there was a mistake elsewhere. Also remember that squaring means the exponent doubles. So if it was like x to the 3rd, it becomes x to the 6th. But yeah, send me what you did, and then maybe if you can send me a picture of your work if that's possible. But if you ask me in WebAssign itself, then I can see what the answer is supposed to be. Okay, how about this guy? What do you use? Conjugate. And I think the quiz question was pretty similar. The most common mistake was just, for lack of a better word, just stupid stuff. Not that you're stupid, but the mistakes were silly. You changed a plus to a minus in the next step when you shouldn't have. Or you didn't cancel things when you should have. They were just silly things that you should know better. Okay. Okay, now multiplying by that, what do you get in the numerator? Over root 9x squared plus x plus 3x. A common mistake I saw grading quizzes is students, they just change this to a minus sign, just magically. I don't know why. Now, before you do anything else, before you do multiplying by stuff to, highest power business, cancel things? Does anything cancel? Good. X over root 9 plus x squared. X over the root 9x squared plus x plus 3x. Okay. Now what do you multiply by? 1 over x. And that 1 over x gets squared when it goes inside the root sign only. You see what I mean by that? So what do you get in the numerator? Okay, in the denominator, what does that 3x become when it multiplies by 1 over x? 3. And in your root, you're going to have 9 plus 1 over x, actually. So then I think that limit is, what do you think it is? 1/6. Good job.
So do you account at all for the positive or negative you can get out of that root?
The root by default always gives a positive, unless otherwise stated. So when I say like find root 4, that means it's 2, not plus or minus 2. If the difference is if you solve an equation x squared equals 4, then when you root both sides, you have to say x equals plus or minus 2. The best explanation that I've gotten for like why when you do that is if the root sign's already there, it means positive. If you add it in a solving process is when you add in the plus minus. Does that make sense? That would be the rule of thumb as to when you know you have to do that. The technical reason is that a function gives one output and is defined to give the positive output. So, all right. Use the definition of a tangent line to find the equation of a tangent I meant to say derivative. Okay, and on your quiz, I realized I made it a little bit harder than your homework questions because I'm going to pretend for a second you don't know it's 1, 3, and I just said at a equals 1. I've given you the x value. How do you find the y value? Plug it in the original equation. So if a or x equals 1, what's the y value when you plug in 1? You get 3. Does that make sense? So that's how you get the second point. You plug this number into the original. Yes? Okay. So what I'll have you do on your test is I'll have you tell me what f prime is, and then use that to get the slope of the tangent line. So the first thing is it's limit h goes to 0, f of x plus h minus f of x all over h. On some of the quizzes you just took, some of you didn't actually tell me what the formula was. You go back and fix that.
We had to tell you what the formula was.
Yes. Sorry. This means to find the derivative. Yes.
When it says derivative, is that, you really want not the f and a,
I wouldn't really care if you gave me the thing with a in it instead of x. I think on the test I was better at specifying, but the quiz I didn't. I just said find the derivative. So in that case, it could have any letter in it you want, but usually it's the same. When it's a function, as opposed to a specific value, usually it's x. But there's so much work in doing the dang problem, I feel like that's really me to take off points for that, so I probably wouldn't do that. And I didn't when I graded these quizzes. So x plus h squared plus 3x plus h minus 1 minus parenthesis x squared plus 3x minus 1. So expand, what is x plus h squared?
X squared plus 2xh plus h squared.
Great. Plus 3x plus 3h minus 1.
What is x squared plus 3x plus 1?
And then it's just like total cancellation city, right? The 2xh is still there, right? H squared is still there, and so is 3h, I believe. Okay. So limit h goes to 0. 2x plus h plus 3. Do you guys agree with that? So now when you plug in 0, what do you get? 2x plus 3. And that's your derivative. It's the function of slopes. Tells you all of these slopes to the graph of f given a specific location. Now at the point you care about, at the 1, 3, your specific m will be f prime of 1, which I think in this case is 5. What you get when you plug 1 into this guy, right? Now given that point and that slope, how do you find the equation? Y minus 3, I believe, equals 5x minus 1.
And stop there.
And stop there, or you could say, if I say get it into slope-intercept form, you'd say 5x minus 2. But if I didn't say to get it into slope-intercept form, you don't have to. And actually, my AP Calc kids, like I told them never to do so unless specified, because if they did and made a mistake, they had points not taken off for it, so they were not specified to get it into slope-intercept, they should just leave it. Because mistakes could happen. Okay. All right, last one. Then you can work on stuff. Find the derivative of x plus 1 over x. Okay, so limit h goes to 0, f of x. Okay, so I'm going to take my 1 over h out. What do you get when you plug in x plus h to that function? And then minus quantity x plus 1 over x. I think we have h plus 1 over x plus h minus 1 over x, right? Because the x's go away. Once the negative distributes, the x's cancel. Okay. What would you like to do next? Besides run away and like not take calculus anymore, okay, other than that. Common denominator, sure. Okay, I like that. What does the h need? H needs the x and the x plus h. What does the x plus h need? And how about the last one? And be careful with parentheses there. Okay. Oh man, okay. So our common denominator, I'm just going to write it down, is x plus h. Okay, in the numerator, the first thing is that this will distribute, right? So hx times x is going to be what? Hx squared plus h squared x, right? Do you agree with that? Yeah, okay, good. Plus x minus h. Is that okay with everybody? So I took this, I know it's a little bit confused. I took this hx, multiplying that by x makes the x squared. Multiplying that by h makes the h squared. You're going to ask for us a different way. What are you going to ask?
Oh, I just went back up to like one of the first top step. What
You
is the-
distributed the 1 over h and you got 1.
No, I was
Okay.
saying, what happened to the minus x? There's supposed to be minus x minus 1 over x.
Oh, did you see there was an x right there?
Oh, okay.
And it canceled the other x. Okay, great. So now this x cancels that x, And now can everybody divide by h? In the numerator, that is? Yeah, so this becomes limit h goes to 0. And the numerator is x squared. Is that right? Plus xh minus 1 over x, x times x plus h. Oh, it is right, okay. So I think that's x squared minus 1 over x squared. Do you agree? Don't agree? You agree? Okay. That's the same thing as 1 minus 1 over x squared. Either answer is okay. Get out the first equals the second? Okay. Alrighty. Good? Okay. Yeah. Alrighty. So that isn't every